Namaskaram everyone, welcome back to the 55th episode of Master Unreal series, and in this episode we are going to work on the gameplay effects. So like I said in the last episode of gameplay attributes, that if you want to manipulate the attributes, the protocol says that you should do it with the gameplay effects. You should not directly update the gameplay attributes of the character, or for that matter any actor. So in this episode, I'm going to show you how you can integrate your gameplay effects with the gameplay attribute, and we will also see how you can listen for the changes in the attributes, like for example health. If the health changes, you will be notified, and then you can update your HUD widgets or any other system that you have in your game. So if you haven't seen the last episode, I highly recommend that, because if you watch that, it will make more sense. So without wasting any time, let's get started. All right, so we are on the project folder this time. We are going to run the solution file because now we are doing C++ as well. So we are going to launch the project from the code base. We created these two classes, base character and the character's basic attribute set. Let's play and make a build. Okay, so the build is successful and now my project will open up. So remember I told you that we are going to use gameplay effects to manipulate the health, because either it's an item that is healing you or an enemy damaging you, the changes are happening in the health. So we will create two gameplay effects. So let's go and create a new folder, and I'm going to call these effects. So we have abilities and we have effects. Let's open this up, and in this I will go for a blueprint class. In the all classes, I'm going to search for gameplay effects. Then I'm going to select next, and I'm going to name it GE gameplay effect heal, which is going to heal me. So this is the effect that the hub will apply. So I'll go in the modifiers and I will add, and the attribute is the character's base attribute set dot health, because we want to update that, and we would like to add in it. And what is it that you want to add? Now, one thing is you fix the amount. Second, it comes from the caller, or basically whatever item that is trying to apply this healing effect, it will provide the value how much health will increase. For example, if you consume the green hub, it's going to restore, let's say, 25 units of health. But if you combine it with red hub, or if you combine it with another green hub, then it's going to give you 50 or maybe 100 units of health. So this magnitude is something that will be decided what type of item you are consuming. So for now, first let's see how it works out when you fix the value. So let's say if you heal, then I'm going to get 50 units of health. So whatever I have, I will add 50 in that, and then I will replace it with the dynamic mechanism. Okay, but for now, let's play with this. I will apply 50 units, and now I need to save it. All right, and now I'll go to my blueprints. I'll go to my player and I'll right click and go for keyboard H, that means H key, and if I press it, I want to heal myself. Okay, so first we are going to see how you can apply the gameplay effect from blueprints, and then we are going to shift that logic into C++. So I'm going to tell you how you can do in blueprints, and then you can convert it into C++ just to get comfortable with the C++ environment. I'm doing this. So when I press H, I want this gameplay effect to be applied. So for this, I need to first get my ability system component, and I'm going to go for make effect context, and then I'm going to go for make outgoing spec, and then I need my ability system component again. So I will connect it, and then the gameplay effect that I want to apply is the heal, and let's pass the level as 1. Now once you have that, you can apply it by calling apply gameplay effect to self. That means the character itself, or basically its ability system. So I'll connect this. Okay, and right after it is applied, I would like to check my health. So we will go get health. Actually, let's use the J keyboard event to check the health. So if I put it here, Okay. So as you all know, my initial health that is in the attribute set is set to 50. So if I heal, it will become 100. So let's play the game. And if I press J, you can see the health is 50 right now. And if I press H and then if I press J, it says I have the health of 100. If I press H again, you say it will say 150. Now here's a catch. You set up the maximum health to 100, but your gameplay effect just increases to 150 because it did not know anything about that. All it cares is just about adding the value based on what you configured in the gameplay effect. So you said just add 50, doesn't matter what is the max health because for the gameplay effect is just a variable. So we need to keep track that we should not go above the max health and we should not also go below the minimum health, which is 0. Okay. So you understood how to create a gameplay effect. It's quite simple. You create a class, you add the modifiers, you provided the attribute and it will do the operation. And then you prepare a context, you set up the spec, and then you apply the gameplay effects. So this is like inventory case where you are applying the effect on yourself by consuming a herb or a medikit. But let's say if it's a damage, then you will use apply gameplay effect to target. Okay. So from the enemy blueprint, you will call this to target, and then in the target, you will pass the player's object reference. Again, separate story, but that's how it works. You got the gist, right? Now let's focus on what we actually wanted to do. This is okay. You are able to apply the effect, but now I need to know if the health is changed. I cannot just press J or input actions to know the health. Someone has to notify so that you can notify other systems, like for example, your widget. So we are going to come back to our code base. So let's handle the first problem that whenever a gameplay effect is applied, we have to make sure that we don't go below 0 and not above the max health. So in the attribute set header file, I will go for public again because it's a function. Under this public, all are variables. Under this public, all are function. I told you you can use these access specifier more than once. So what I want to say here is that if a gameplay effect is applied, which is interacting with these attributes, then I want to be notified. So for that, there is already a function which you can override. So let's have a look in the architecture. There is this door. Do you remember I created a base door class and then I asked you to derive whatever doors you want to make? Because in there, you just have to replace the door mesh and the implementation will come from the base class, from the parent class. And you can change or override what you implemented in the base. So do you remember, like, for example, if I place this single base door here and let me rotate it like this. Now this is a base class and this is another door that we created from this base class and it has a lock on it. So if I play and I get to kick the door, but if I press E here, it first plugs in the key and then unlocks the door. And now you can press E to kick the door, right? So if I recall, in the single door base, you have this on interact and single tap. But when you tap on a locked door, you first want it to be unlocked. So what you did in the single door with lock, you overrided the single tap functionality which you implemented here. You see, this is the parent class. You call the on interact and then you prepare the player. But instead, now you call the on interact and first you open the lock. And once the lock is open, then if you press E, then you are calling the prepare player. So basically you override it, right? So that's what we are going to do here as well. The gas system already gives you a function and you can implement your own logic inside it. You don't have to create a new function for that. And that function is virtual void post gameplay effects execute. That means after this gameplay effect has been executed, this function will be called and the parameter that it will bring is f gameplay effect mod callback data, and it's going to be reference and we are going to override it. That means we want to implement our own logic. So like I said, if you declare any function here, you are going to implement it. Now, this is not something that Blueprint has to think about. This is something that is happening internal in our class. So we will not specify u function the way we did it in the character class by writing here. Okay, and now we are going to implement this. So we will go to C++ and we will read as it is. This is void. That means it is not going to return anything. Void, then the class name. So this is the class name. And then the function that I want to implement is the post gameplay effect execute. And then the parameter was f gameplay effect mod callback data. Okay, so this is a function that is already there. We are just overriding it with our logic. If it was implemented by the attribute set class, because remember this function is present in the attribute set. You are creating a class that is derived from this attribute set. Now this attribute set has this function which you want to override so that you can write your own logic and get it executed. But that doesn't mean you want to interrupt the attribute sets implementation. The developer who created this class also has an implementation, so we want to call it, and once it is done, then we would like to call ours. So just like the begin play I showed you in the previous episode. So the way is you use super, which means the parent class, we will call this function and we will pass the data, and once it is done, then we would like our logic to be executed. And now we would like to access some information from this data, which is of type this class, and we have to include its header file so that we can access, because if you try, I would like to access the data, but nothing is showing up. So what you are going to do is you are going to include it. So we are going to say include gameplay effect extension. Let's try again. Data dot, you see, now you got the suggestions because this type that is of struct is present in this class, that is gameplay effect extension. So I told you in the previous episode, if you want to access from something from the class, then you always include it. So now I'm gonna go for if data dot evaluated data dot attribute is equals to get health attribute. Now what are we doing here? See, this attribute set has more than one attribute. There is a health, there is a max health, you might have stamina or you might have a mana. The point is you have more than one attributes. So this post gameplay effect execute will be called every time a attribute in this particular class, in this attribute set, is modified. So we are going to write the logic for the health. So first of all, we have to ensure that the data that has been changed or the gameplay effect which has been applied on the attribute is the health attribute. So if it's a health attribute, then we would like to do something. So what do we want to do? We have to make sure that the new value of the health should lie between 0 to the max health. So I will get float new health after the gameplay effect is applied. So how to get the current health? Just call get health. Remember the getter we created, we are getting the value. So get health, and now we would like to put this between 0 to max health. So what I'm going to do, I'm going to call fmath, and I want to access its function called clamp. What it will do, it will take this value, which is the current health value, and we are going to clamp it between 0 to the max health. So get max health. You see, clamps x to be between min and max inclusive. So that's what we want. This is the valid new health, and that's it. We are going to set it. So remember, you call set health just like you have get health, and now you provide the value that is your new health. Great. So we take care of the first situation. Would you like to try out? I will write one more logic. If this new health that we set, if it is less than or equal to 0.0 float, then I would like to get a log that player died. Okay, if your health is 0 or below 0, that means basically the player died. So if this function is running successfully, I will get this log. Okay, so there is an error. Sorry, I did not check the attributes. First of all, we have to provide the category name. So that is log temp. Then we would like to show it as a warning and then the message. So go for text. Okay, now it's good. So we will get a log. Let's see. What I'll do, I'll create one more gameplay effect in the blueprints and blueprint class, and I will say gameplay effect, and this is going to be GE damage. Okay. Okay, I wrote all caps. That's bad. I'll open this up. Same thing, we are going to add a modifier, and the attribute that we are trying to touch is the health, and we would like to subtract. So use add base and subtract, give a negative value, so it will subtract. There is no subtract, you have to use add. So I'll say -10, or let's just go for something really high. -50 is good. So compile and save all. I'm going to go in my blueprints player, and you see H is for healing, and I'll create another one that is G. I'll click on this keyboard and press G, and I'm going to construct the gameplay effect. Let me remove this, and this time it is going to be damage. So if I compile and okay, oh sorry, we have to plug this. Compile and we go back to map and we press on this. All right, compilation is successful. Now if I play and if I press J, you see my health is 50. If I heal, it is 100. If I heal again, it is still 100. You are not going more than 100 because that is the max health you set. You see, no matter how many times I press H. But if I press G, and now if I press J, you see my health is reduced. It's 50. And now if I press G again, my player is dead. You can see my health is 0. So in the output log, you will find the warning player died. All right, and you can see these are the values that were coming all the way along. So that summarized that this function is running just fine. So now I can comment this out because I no longer need it. I was just doing this for testing. So this is for sure that your health value is not going below 0 nor more than the max health. That is done. Okay, so now when this health change via damage or via healable, I would like to be notified in the blueprints so that I can do my work. So for example, if I'm 0, then I would like to die and make the character disabled. And if I am receiving some health, then of course, in both the cases, I have to update my user widget, right? The HUD that I'm going to have in my game. I would like to update the values over there. So I'm not going to do all that in C++. I want to do in blueprints. So something has to notify that health is changed. So for this, I'm going to go in the base character H header file basically, and I'm going to create an event. So what is it that we are going to do? When the attribute inside this base attributes, that is health, if this changes, I would like to be notified. So how do we work out that? Using event dispatcher and listeners. Remember the tag manager we built? Whenever the running state changes, you are notified. You see, when the locomotion changes, you are notified. When you change your stance, everyone is notified. So everyone uses this add tag listener to bind, and then whenever this tag changes, we get notified. So we are going to use this event dispatcher and listener to listen for the health change. And do you know, you can pass a delegate event and then you can bind to it, and then whatever you want to do, you can do. If you do not know this, I highly recommend you check out the gameplay tag manager. I have explained it in a great detail. So now we are going to do that in the C++. So again, we are not doing anything new. I'm just writing the same thing in C++. So first of all, I would like to go to header of base character, and I would like to create an event which I would like to bind to the health change. So I'm going to go for void on health changed, and I would like to receive that data. That was f on attribute change data, and I want reference of it. So you see now I'm using a structure class or type from a class that is gameplay effect. So now I can no longer rely on this declaration, I have to include its header file because I'm trying to access something from inside that class. So I'll say include gameplay effect, okay, types dot h. It's okay, you don't have to by heart, just know that this comes from this gameplay effect types dot h. Great, now since we have it, we have to implement and use it. Okay, so first thing, we have to bind this event so that it can be called. So we have to go for event begin play of base character dot cpp, because when the game loads, I would like to bind so that I can start listening for the events. So I'm gonna check if my ability system component is valid. If it is valid, then I would like to bind to the attribute. So f gameplay attribute, that is your health attribute. So first you have to get that attribute. So this attribute is coming from this class. So get the class name, double colon, get health attribute. Okay, so before we bind it, do you know that you also have to unbind if your character dies? Remember in the tag manager, I told you if you want to listen for a tag, you call this add tag listener and then you bind the event. But once your job is done, you call this remove tag listener, which will unbind it. We do not want to consume resources if we don't need it. So basically when the player is dead or it is destroyed from the game world, then we want to unbind so that it does not consume the resources. So for that, I have to store this information. So for this, I'm going to go in header and I'm going to create a variable. And this variable is not present in blueprints. It is supposed to be used in the internal purposes. So I'm not gonna expose it to the blueprints. And the type of that variable is fdelegates handle. And the variable name is health change handle. Now, if you're wondering how I came up with this type, do you remember this event? This is the delegate type. So that is this one. Okay, so we are going to store it in this variable. So health change handle. And now you are going to store what? The binding information. For that, first we have to go to the ability system component and we have to say get the gameplay attribute value change delegate. And now we would like to give him the attribute, which is the health attribute. So now you have the reference. And you can continue after this one and you can say add uObject, which is this, and you want to pass the reference of the event or the function that you created, which is the on health change. So copy. So first you have to tell the class. So I'm accessing from my base character. So I'm going to write a base character. And now what am I accessing is the on health changed. So when this attribute will change, it will call this function. All right. So you pass the reference of this class and the function that you want to get called. Now, when this changes, you will be called. So we have to implement it. And that is void on health changed parenthesis, and this will be called. See, so simple. And now we would like to receive the value as well. So that is what we declared there. So let's copy this, paste it here. So this is the input. Now this data contains the old value and the new value that is present right now after the effect is applied. So we have both the values, the value before the effect is applied and the value after the effect is applied, which we want to send to blueprints if they want. So what we are going to do, we are going to create one more event which is present in the blueprints. So I'll say it's an event because it is not returning anything. So we say void BP on health changed. Okay, so this is for blueprints. And what do we want to give them? The old value and the new value. So I'll say float old value. That means the value which was there before the effect was applied, and the new value. Okay, and I want this to be in blueprints. So I have to define it, u function, and I want to implement it. Okay, hold on. Now, this is just a declaration, right? Just like you're declaring everything else, you are also going to declare it. but the implementation will happen in the blueprints. Now it will not happen like this in C++. This will happen in blueprints because that's what we want. So we will say blueprint implementable event, and the category, let's give it attributes. I hope this makes sense. Okay, so we go back to C++, and this is the on health change, which will be called when the attribute value changes, and we are going to call the, oh, I forgot to use the class name, my bad. Okay, so class name and then the function name. Okay, and now we are going to call bp on health change, and now we have to pass the old and the new value. So that is coming from data old value, data new value. Okay, that's it. We can go back to our game, and now we can click on this so that the code is compiled. Let's see if there are any errors. Okay, so the build was successful, and if I go to player now you will right click and search for BP on health change. You see you have the event. Now you can do whatever you want. Notify in the widget blueprint to change the value. For now, I'll just go for print string, and I'll connect this new value. Or let's do both. I'll call for string append. First, I'll say old value, and then I'll give some space, and then I will plug the C. So first one is the old, second one is the new, and I'm going to connect this. And I'm going to expand this, and I'm going to set its duration to 20. And now I'm going to play, and first I'm going to hit H. Remember, my initial health is 50 and the maximum health is 100. So as soon as I press H, this will become 100. So here's my game. If I press H, you see first it was 50, then it was 100. Now you will be wondering why it is logging 2 times. It is logging 2 times because first the gameplay effect changed the value, which is okay, and then you changed the value here in the post gameplay effect. So you changed the value 2 times. Now we should not do this. We should only do this if the value is not between 0 and max health. So what we will do, if this new health that we calculated, if it is not equal to the current health value, then we are going to update it so that it does not change the value 2 times. Oh, I'm sorry, I'm a web developer, so sometimes I just use equal to 2 times. Okay, so this is going to compare. So only if you go out of the range, this will be a new value, and then only we are going to update it. So I'm going to close the game, and I'm going to go back to level map, and I'm going to hit this again. Okay, build is succeeded. Let's play. If I press H, you see it only appears once, and it says older value was 50 and then it got 100. Let's press H again. Now you see the older value was 150 and the newer value is 100 because we were going out of the range. If I press G, that is to damage, you see it was 100, now it became 50. If I press again, it became 50 and 0, and I cannot go below 0. See, I tried, it made minus 50, but then the post gameplay effect corrected to 0. Okay, so you are getting notified in your blueprints, and now you can call widget or whatever, and you can update your HUD or anything like that. Okay, so we have done the health change, and now we go to CPP and we have to unbind it. So where it is in the base characters CPP. So remember, you binded it. Now you have to unbind if the player dies, or basically when your character is destroyed. So when the character is destroyed, the instance of it is destroyed, there is something called as end play, which is called just like when your character gets created in the game, it calls the begin play. When it gets destroyed, it calls the end play. So in the base character H, you are going to create that function. And again, this function already comes with the parent class. So we are going to override, just like you override at the begin play. So it is a protected function. So we will go under protected specifier. I'll go for virtual void end play, and I would like to override. And it has a input that is your end play reason. And I would like to access its type. And the variable name is end play reason. Okay, so this is the function that is already present in the base character class, this one, and you are trying to override it. So let's copy this and play completely. We go to CPP of base character, and right below the begin play, I'll do this end play as well. And let's correct ourselves. You have to specify the class and then the function that you are trying to implement. Okay, so what is it that you want to do? You have to unbind. So to unbind, first of all, let's make sure our ability system component is valid. We are going to get our health attribute. Let's copy this. And then we are going to get the ability system component. Now we don't want to store, we just want to unbind. So get gameplay attribute value change delegates, and that is your health attribute. And I would like to remove. What is it that you want to remove? The health change handle, where you have the reference of the binding. So we are going to do this. And once this is done, then we would like to call the end play of the parent. Why I'm saying this is because if you did this before, then you will lose your ability system component and all the other components. So we want end play to work out, but only once we are done with our logic. So you can control how you want to execute the parent implementation. And let's pass the end play reason in the input. Okay, so that's how it works out. Now you go back to your game and hit this live coding again, and it will compile. Now I told you that in gameplay effects, this healing and damage can vary based on the type of enemy or based on type of health. So you want this magnitude to be dynamic. You want this to be updated dynamically based on the character or based on the healable item, right? So there is an option for that, and you can select it and you can say set by caller. So whoever is calling this gameplay effect, they can set their own value. So if you change this to set by caller, then in this you have to provide the tag. So for this, I'm going to go and manage gameplay tags, and we are going to create data.health. And I'm going to add this. So we have to receive the value. So you have to provide the data name and the tag, but the name is not editable here. So I'll go for data tag, and that is your data health that we created. Okay. So when the caller who is applying this gameplay effect, that is damage, whoever is going to give the damage can set the value, and the value will be mapped to this health. And we are going to use this key to read the value. Same applies for the heal. You can change this to set by caller, and you can go data.health. Great. So how do we use this? Let's go back to blueprints, player. We are going to use player because right now we don't have the shooting damage and all that set up. So right after the spec is created, I don't want to apply the effect. I want to set the magnitude. So set or assign tag set by caller magnitude. So you will call this, and now you can provide that data.health, and you can provide what is the magnitude. So let's say I want to damage, and I want to damage minus 30. And then after that, I would like to apply this gameplay effect. Okay. I always forget this. Okay. Now, similarly, we have the damage. We also have the health. So this time I do not want to make a healing of 50. I only want to heal 20. Let's say there's a herb that heals only 20. Right now we don't have it. In the next episode, we will have it. So I'm going to go for this one and connect this, and we go rest, and I'll say I want to apply health of 20. So now we compile, and if I play, you press G, you got damage of 30, which you set here. If I press H, I get healed by 20. You can see it was 20 and now it became 40. So it got healed after the damage. Okay, so that's how you can assign the magnitude based on what is applying this gameplay effect. So that's it for this video, guys. I hope you enjoyed it. And this was the basic application of the gameplay effects and how you can manipulate the gameplay attributes data with the help of gameplay effects. And now we are going to take one more step further by integrating our inventory with this gas system. So the idea is to make our inventory modular and dynamic, which means, for example, if you have an item, for example, a hub, we will use that item to apply a gameplay effect, and that will change the attributes. Apart from this, I also want to show you a new system that is being taken from Lyra, which is called fragments, which allow you to make your items modular and dynamic without messing up the whole thing. So in the next video, we are going to work on our inventory back, and we are going to integrate this gameplay effect so that the items of the inventory can manipulate them. So like the video, share it with your friends, subscribe to the channel, and if you like my work and you want to support me, the Patreon link is in the description, and do reach out to me before buying any membership, and I'll see you in the next video.